Right now, your company's old, boring back-end systems aren't just sitting idle. I mean, they are actively burning up to like 25% of your IT budget,
Yeah.
and there is a very good chance no one on your executive team has any idea it's even happening.
Oh, absolutely. It is this massive financial drain, but it's masquerading as a routine technical chore.
Yep.
People tend to look at an ancient server or, a decades-old software interface like a heavy piece of antique furniture.
Right, nobody wants to move it.
Exactly. Nobody wants to move it, but everyone assumes it's completely harmless just sitting there in the corner.
And that is the exact illusion we are breaking today. Welcome to the Deep Dive. We are unpacking a really fantastic article from Code Aura titled The Hidden Economics of Legacy Systems, Why They Cost More Than You Think.
It's a great piece.
It really is. And our mission for this deep dive is to completely flip how you view outdated technology. We need to take it out of the IT department's complaint box, put it right where it belongs, which is on the balance sheet as a compounding financial liability.
Yeah, the source material identifies a fascinating blind spot at the executive level. Because, you have to wonder how the people controlling the money miss something so massive.
Right. How do you just lose that much of the budget?
Well, it ultimately comes down to how organizations categorize their expenses. Because legacy systems are universally treated as a tech concern, the costs generated by them are scattered. They're just scattered across different departments.
Okay, let's unpack this blind spot.
Yeah.
If the costs are scattered, what are the different executives actually seeing from, their individual vantage points?
So they are all seeing different symptoms. The chief information officer, right, they look at the quarterly reports and see maintenance overhead steadily climbing.
Just general upkeep costs.
Exactly. But the chief technology officer isn't looking at maintenance. They're looking at velocity. They're noticing that software delivery cycles are dragging on for months.
Right. Everything is just taking way too long to build.
Right. And then the chief financial officer is looking at general budget creep, but they can't pin it to a single bad investment.
They just see the money leaving.
Yeah. Meanwhile, the chief risk officer is bogged down in these increasingly complex compliance audits.
So everyone is staring at their own dashboard, seeing a red flashing light. But because the lights are labeled differently, maintenance, velocity, budget, risk, no one realizes they're all wired to the exact same broken machine.
That's spot on. They never appear as a single, unified, measurable line item.
Wow.
And that fragmentation is what keeps the real financial burden hidden in plain sight.
To really understand these hidden costs, I think we first have to look at what executives actually do see, because that visible part of the budget is what gives them this false sense of control.
Oh, for sure.
The article outlines 3 visible costs that are routinely budgeted for. We've got maintenance, infrastructure, and proprietary licensing fees.
Yeah, those are the big 3, and I mean, they are incredibly expensive on their own. Maintaining a legacy environment requires constant manual intervention.
Like patching security vulnerabilities.
Yeah, patching systems that aren't officially supported anymore, or tweaking compatibility just so a modern web browser can talk to a 20-year-old database. It's just constant bug fixes.
Just keeping it alive.
Right. And the industry benchmark Code Aura points out is striking. Simply maintaining a legacy system costs 20 to 25% more than supporting a modern cloud-native platform.
Wow, a 25% premium just to keep the lights on. And that doesn't even factor in the physical infrastructure, right? I mean, old technology is notoriously power hungry.
Oh, massively. You have on-premise servers consuming massive amounts of electricity, requiring specialized cooling, taking up literal real estate in a building somewhere.
Yeah, and then there are the escalating proprietary licensing fees.
Well, the licensing model for legacy tech is often predatory by design.
Oh, really?
Yeah, vendors know that a company is completely terrified to migrate away from a legacy database because it holds all their critical customer data. So what do? The vendor steadily increases the licensing fee every single year.
Because they know you can't leave.
Exactly, you're trapped. Organizations look at these visible costs, the maintenance, the power, the licenses, and they normalize them. They just accept them as the unavoidable cost of doing business.
It's like paying exorbitant rent for a house with a leaky roof. You sit at the kitchen table every month, frustrated by how high the rent is, which you could physically see leaving your bank account.
Right.
You might even call the landlord to negotiate like $100 off. But while you were focused on the rent, you are completely ignoring the fact that the water damage inside the walls is actively rotting the structural beams of the house.
That is a great way to put it.
You are trying to optimize surface-level expenses while tens of thousands of dollars in structural decay just spreads through the foundation.
Yeah, the normalization of the rent blinds you to the rot. In a corporate environment, that structural decay is the daily operational friction caused by these old systems.
So let's look inside those damp, rotting walls. We really need to talk about the engineers, the people actually trying to build new features while living inside this structural decay. Because if the visible costs are the rent, the water damage is what happens to engineering productivity. And the data on this is just staggering.
The source material focuses really heavily on the productivity drag. Modern engineering velocity relies on absolute clarity.
Right.
A developer needs to understand how a system works in order to build on top of it safely. Legacy systems offer the exact opposite of clarity.
A mess.
They force highly paid engineers into this endless cycle of deciphering poorly documented, heavily entangled code.
Okay, the stat that should make literally any executive's stomach drop is this. Developers operating in legacy environments lose up to 17 hours per week just navigating inefficiencies.
Yeah.
17 hours. That is almost half a standard work week spent doing absolutely nothing productive.
I know, it sounds wild. But to understand how that happens, you have to look at the mechanics of their day. A developer isn't just staring blankly at a screen for 17 hours.
Right, they're working, just not effectively.
Exactly. They are basically acting as an archaeologist. They are assigned a simple task like adding a new field to a customer checkout page.
Seems easy enough.
Right. But to do that, they have to trace a single variable through thousands of lines of spaghetti code written back in 2004.
Oh, wow.
They run a test, it fails, and then they spend 5 hours trying to figure out why an undocumented database column is suddenly rejecting the change.
Okay, so I'm looking at this 17-hour number, and I'm genuinely confused from a management perspective.
How so?
Well, if you know your team is bogged down deciphering old code and you have a massive product deadline coming up, why wouldn't a company just hire 5 more developers? Like, just throw bodies at the problem, shoulder the load, and brute force the work to speed things up.
It makes sense on paper, but adding resources to an opaque system actually scales the inefficiency. It makes the problem way worse.
Wait, really? How does more help make it worse?
Imagine a massive, complex maze that is pitch black. Sending 10 people into the dark maze instead of 2 doesn't generate any light.
Ah, I see.
It just means you now have 10 people bumping into walls, and worse, bumping into each other. More developers trying to alter code they don't understand leads to more communication overhead, more merged code conflicts, and ultimately just more broken features.
So the financial risk here isn't the outdated technology itself, it is this widening knowledge gap.
Exactly.
Because the people who actually know where the light switches are in that maze aren't going to be around forever. The article brings up this concept of tribal knowledge, which feels particularly dangerous in industries like banking, healthcare, and manufacturing.
Oh, tribal knowledge is huge. It refers to the critical business logic, the bizarre edge cases, and all the specific system behaviors that are not written down in any official manual anywhere.
They just live in someone's head.
Right. They exist solely in the memories of a few senior engineers who helped build the system 20 years ago. The entire operation is basically held together by 3 people who know that, like, if you touch the payment module on a Tuesday, the whole system crashes.
That is terrifying.
And those individuals are rapidly approaching retirement age.
So when they retire, they take the blueprints to the maze, right out the door with them.
They walk out the door and the knowledge vanishes overnight. And the cost of trying to rebuild that understanding is astronomical.
I can imagine.
You end up paying exorbitant consulting fees or dealing with onboarding periods for new engineers that stretch from weeks into months because the new hires have absolutely no idea what they are even looking at.
So we have new engineers guessing in the dark, losing almost half their work week, while the veterans with the blueprints are retiring. That inevitably leads to the next layer of this financial nightmare. What happens when an engineer guesses wrong?
That's when you get the ripple effect. Legacy systems suffer from what we call tight coupling.
Okay, what does that mean?
In a modern architecture, different features are separated into distinct modules. If one breaks, the others keep running. But in a legacy system, everything is tangled together in one giant monolithic block.
It's like playing a game of Jenga. where someone had secretly glued half the pieces together.
Yes.
You try to carefully slide out a block near the top, and the entire bottom half of the tower violently shifts.
Yeah.
You fix a typo on the homepage, and suddenly the payroll system crashes.
Exactly. And that triggers a vicious operational cycle. Build, break, investigate, fix, retest.
That sounds exhausting.
It is. The developer pushes a small update, the system breaks in a completely unexpected place. Now, instead of moving on to the next task, they have to launch a full forensic investigation into why the payroll system cares about a typo on the homepage.
Right.
They apply a fix, run the entire testing suite again, and just pray nothing else breaks. Each step consumes massive amounts of time.
And when those errors slip past the testing phase and actually hit production, the stakes go through the roof.
Oh, absolutely. Diagnosing a root cause in a monolithic, undocumented system takes significantly longer than it would in a modern environment. In banking, for example, if a transaction gateway goes down, you aren't just looking at an annoyed IT team.
You're losing real money.
You are looking at immediate, measurable revenue loss by the minute. You are looking at customers who can't access their funds, which leads to severe reputational damage.
Well, here's where it gets really interesting. The part of the Codora article that completely shifted my perspective on this was the regulatory peril.
Oh, the compliance side.
Yeah, we aren't just talking about a website being temporarily slow. We were talking about serious compliance failures. Organizations in regulated industries have to adhere to incredibly strict frameworks. You have HIPAA in healthcare protecting patient data, Basel V in banking, NIST for cybersecurity.
And those regulatory frameworks demand absolute transparency. An auditor will walk in and demand to know exactly how a piece of sensitive customer data moves from the moment it is collected through your processing layers to where it is stored.
Now, on the surface, that sounds simple, right? Just run a search for the data and print out the logs. Why is tracing data so difficult in an older environment?
Because legacy systems were not built with modern data governance in mind. There is often very little metadata, which is basically data that describes other data.
Okay.
So customer information might be stored in a table with a completely obscure acronym for a name. It might be processed by a batch job that runs automatically at 2 in the morning, moving the data to some disconnected mainframe.
Oh, so it's basically hidden.
Exactly. When an organization tries to trace that flow for an auditor, they are essentially trying to trace invisible ink.
Which means they have to retroactively force compliance onto a system that is actively resisting it. Going back to our housing analogy earlier, it is like trying to install a state-of-the-art smart home security system into a 100-year-old mansion.
Yeah, good luck with that.
Right, you don't have the electrical blueprints, you don't know the layout of the wiring behind the plaster, and you honestly don't even know how many doors the place has. You are just ripping open walls, stringing wires, and hoping the alarms work when someone breaks in.
And that creates a state of non-compliance by obscurity.
Non-compliance by obscurity. I like that.
Yeah, because most established companies are not acting maliciously. They aren't intentionally breaking regulatory rules or hiding data from auditors. They simply have no idea where their own sensitive data lives or how it is being processed by these decades-old routines.
The system is entirely obscure to the people running it.
Precisely. And when that audit happens, the sheer panic of manual evidence collection, the scrambling, the emergency consulting fees, that becomes a massive unbudgeted expense that hits the bottom line hard.
So if you are an executive realizing that your company is hemorrhaging money through lost 17-hour work weeks, constant rework cycles, and the looming threat of massive regulatory fines, the immediate human instinct is panic.
Oh, total panic.
The instinct is to say, burn it down, rip it all out, move everything to the cloud immediately. But the source material is very clear that giving into that panic is exactly the wrong move.
Yeah, the industry calls that panic response a lift and shift migration.
Lift and shift.
You take the existing, poorly documented, tightly coupled legacy codebase, and you simply move it onto a modern, fast cloud server.
But why does that fail? I mean, if the old server is the problem, doesn't putting it on a faster cloud server at least stop the bleeding?
Because the physical server is only a fraction of the problem. If you lift and shift, you are taking all the hidden costs, all the complex ambiguity, and all the tight coupling right along with you.
Ah, so you just transplanted the issue.
You haven't solved the productivity drag at all. You just moved the dark maze to a new address. The developers are still going to lose 17 hours a week trying to decipher the spaghetti code, except now you are paying a premium cloud hosting fee to run that inefficient code.
That makes total sense.
Modernization cannot begin with transformation. It has to begin with clarity.
The article actually outlines 3 core principles for fixing this mess intelligently. First, document before you transform. Second, understand before you migrate. And third, optimize before you rebuild.
Yes.
This is where Codeor's specific approach really shifts the paradigm, using AI not as a tool to write code, but as a cost elimination engine.
Exactly. Instead of hiring an army of human consultants to spend 2 years reading old code and writing static manuals that will be outdated the second they are published, they deploy AI to map the environment dynamically.
I really want to break down how that actually works, because it sounds a bit like magic. How does an AI platform come into a 20-year-old system and document it?
Well, AI models are trained on legacy syntax. They can ingest millions of lines of archaic COBOL or outdated Java and parse the logic at a speed humans simply cannot match.
They just write it all at once.
Right. A human engineer gets fatigued, loses track of variable across 40 different files, and misses connections. The AI doesn't. It maps every single dependency.
Wow.
It can find every single place in the code base where a specific customer ID is touched, altered, or stored. It extracts the underlying business logic directly from the raw code.
And that leads to my favorite part of this strategy, which is natural language querying. Once the AI maps the system, it allows developers to ask questions about the architecture in plain English.
It's incredible.
Instead of a junior developer spending 3 days running searches to figure out how the payment gateway works, they can simply type, "How does the payroll module connect to the HR database?" and get an instant contextual answer based on the actual code base.
It fundamentally eliminates the 17-hour productivity drag and neutralizes the fragility of tribal knowledge we talked about earlier.
Right.
By creating a continuous real-time map of the system, it transforms an opaque, risky environment into a transparent, measurable one.
So what does this all mean? It takes this terrifying, high-risk capital expense, the feeling of, oh no, the servers are dying, we have to spend $50 million to rewrite everything right now, and turns it into a controlled, value-driven investment.
Precisely.
You are mapping the house, finding the rot, and repairing the structural beams before you even think about moving the furniture.
And it forces organizations to ask a critical question. Are you modernizing just to change your technology's address, simply to check a box for the board that says, "We are in the cloud now"? Or are you modernizing to actually eliminate the hidden financial rot that is dragging down your engineering teams and putting your enterprise at regulatory risk?
That really is the defining question for any tech leader today. As we wrap up today's deep dive, let's take a quick look back at the journey we went on. We started by looking at legacy systems as a passive annoyance, the visible rent you have to pay for maintenance, power, and licenses. But we discovered that the true cost is the water damage inside the walls.
It is the systemic underestimation of operational friction.
Yeah, it's the 17 wasted hours a week per developer, lost in a dark maze of undocumented code. It's the terrifying fragility of tribal knowledge walking out the door when your senior staff retires. It's the endless cycle of tight coupling, where fixing a typo breaks the payroll system, leading to downtime and revenue loss. And it's the panic of retrofitting regulatory compliance onto systems by tracing invisible ink. The true cost of legacy tech is everything you cannot see on the balance sheet.
It is a financial liability that compounds every single day you ignore it.
So, the next time you were sitting at work, waiting endlessly for what seems like a simple new tech feature to roll out, or wondering why a minor bug is taking 3 weeks to fix, you now know what's really going on. You know about the invisible 17-hour battle happening behind the scenes, deep in the legacy codebase.
We have spent a lot of time today talking about how AI is the ultimate solution to this problem. It extracts, documents, and translates the arcane business logic, saving us from the disaster of the retiring engineer walking out the door with all the secrets.
Right, which is great.
It is great. But if an AI platform perfectly maps and deciphers decades of legacy code, and it does it more comprehensively than the human staff ever could, at what point does the AI become the only entity in the organization that truly understands how the business fundamentally operates?
Oh, wow.
We solve the human dependency by creating a massive machine dependency. What happens when the tribal knowledge is entirely held by the machine?
A brilliant and slightly terrifying paradox to leave us with. Something to chew on the next time you look at that blinking server in the basement closet. Thanks for joining us on this deep dive. We'll see you next time.